Good morning, everyone. My name is Molly Tenbrook, and I want to thank you all for joining us today for our webinar. Today's webinar will focus on Questa verification management. Before we jump in, I would like to give you a brief introduction to Trilogic and what we do. For over 30 years, Trilogic has provided software and services enabling engineering groups to design, develop, and deliver products through excellent support, training, and consulting services to help you achieve success sooner. Oasis Sales has been a mentor premier partner for over 16 years. Their industry knowledge and experience make them uniquely qualified to understand your business and how technology will make their customers successful. As you can see highlighted here on the map are the regions that each Oasis and Trilogic cover. Here you can see the different design and product management areas that Trilogic covers. You'll notice that we've tried to create a suite of products that will provide a front-to-back solutions all the way from concept to end of life. Make sure that you're subscribed to our YouTube channel. We upload our webinars there. You'll be able to view the recording. You can use the link below or by searching Trilogic on YouTube to subscribe. And now I would like to introduce our presenter today, Walter Goody. Walter has over 25 years of experience in ASIC and FPGA design and holds an MS in electrical engineering from Washington University in St. Louis. He worked for 6 years doing ASIC design at Tel Labs operations. From there, he went to work for Mentor Consulting, where he consulted on various ASIC projects, including time spent in München, Germany, and Helsinki, Finland. For the last decade, Walter has worked as an applications engineer, supporting Mentor's line of functional verification products. Please welcome Walter.
All right. So as Molly said, today's webinar is on our Questa verification management toolset. This is part of the Questa Prime tools, and it is an optional add-on to Questa Core. A few things to set up. You look at modern projects today, you'll see some pain points. Some of them might be that you have design teams that are spread across potentially the globe in lots of different time zones. You have a lot of engineers with different skill sets, lots of different methodologies. You have different tools that are creating the data, and the schedules are always quite aggressive. So we kind of look at three different dimensions of things that you have to manage. You have the data being generated, the process for verification, and then all the tools that are needed to do that. And then verification is all about answering, a lot of these questions, like, who's responsible? Where are we in the schedule? What risks do we have? What simulator engine should we use? But it really all comes down to when are we done? And so the Questa verification management tools try to answer all of these different questions. So the verification management tools we'll talk about today all focus on like the verification planning, regression management, analyzing your coverage, analyzing your results from your simulation, and some trend analysis. We do also have other tools from Mentor that complement these things. So for requirements management, we have RecTracer, which is our requirements tracing tool. And then for these other pieces of the puzzle, we have an integration with the Jenkins continuous automation tool, and I'll show you just a couple of slides on that at the end. So really it all comes down to managing the data. And this presentation will show how our verification management fits into what we call our enterprise verification platform. And so what that enterprise verification platform is all about is being able to use different engines. So we're going to talk probably mostly about the Questa simulation engine, but our Questa formal tools, our Veloce emulator, our FPGA prototyping tools, our Vista virtual prototyping tools, they all produce the same type of data and all fit into this verification infrastructure. And it's all about managing and analyzing the coverage. And it all kind of starts with our unified coverage database. From that unified coverage database, all these different tools will create a compatible database that can be merged and ranked and all the different things we can do. We have tools to help guide that process. We have a connection to your verification plan so that you can see how your verification results annotate your verification plan. And then finally, we have the verification run manager to help us automate a lot of these processes. So as I said before, the verification process comes down to, or the whole verification management comes down to kind of three different aspects. You have the verification process, which is, your verification plan, your specification, the methodologies you're going to use. There's the verification tools you're going to use, Questa Sim probably being the one most of you would look at, but also maybe hardware, software, co-simulation, prototyping, some formal tools, and then all the data that you generate. So these three aspects are all part of our verification management solution. And so on the data management side, it all starts with our unified coverage database. So that is the database structure that Mentor created about, I'd say it's been about 15 years ago now that we created the UCDB database. That is our central database, but then that database has become the basis for what's called the UCIS, that is the Accelera standard database. So the implementation of the database from other companies could be different, but in theory, different companies can all have their own implementation of the UCIS and have a common API so that data can be shared across company tools. So the process management is where we link in our your test plan to the verification metrics that you collect either in simulation or whatever other engine you use. Trend analysis is looking at that coverage and how it is changing over time so that you can, see if you're zeroing in on being finished. The results analysis part of it is making sense of the failing tests. So if you have a giant regression suite that runs hundreds and hundreds of tests, and maybe you have 50 failing tests in a regression run, do you want to individually debug each of those 50 tests? Or with our results analysis, what you can do is you can look at the merged results of all of them and say, hey, you know what? At 267 microseconds, this error message got put out in 35 of these 50 tests. So if we debug that one message that all was happening at the same time, we're simultaneously debugging those 35 failures. And so that's basically what the results analysis is being more efficient in your debug. And then our regression run manager is the thing that pulls it all together, controls all the different multiple tools. It is a common way to create your build scripts and your run scripts and everything else. And if you do it through a regression run manager, that automates a lot of the downstream tasks like merging the coverage data together, merging that with your test plan, and rerunning simulations that fail and things like that. So I'll show you all of these aspects, but we're going to start with that UCDB database. So when we are looking at running a test, any test we run is going to create some coverage data. So that might be code coverage if you're just doing a test bench and you don't have, you're not doing system verilog. You might have finite state machine coverage. Functional coverage is your cover points and cover groups, and then your assertions and your cover directives generate coverage data. You may be getting other coverage from maybe formal verification tools, verification IP. There may be custom user data that you want to put into that database. And finally, all of this data that you're collecting, you'd like to match that up with your verification plan to see what in your verification plan has been tested and finished. And so that test data, all of these different pieces, the question was, how do we manage all that effectively? And how can we use this, and that is where the UCDB originally came from. We originally looked at using like a SQL database or, an Oracle database, and quickly decided that coverage had its own set of issues, and so we created our own custom database called the Unified Coverage Database, UCDB. And we published the read API and the write API for that, so that we can put things into there, but because you have a write API and a read API, you can put your own coverage in there as well. You can customize that. You can write tools to add your data. You can link your test plan. You can link all kinds of other things into that UCDB. And these APIs that we donated to the Accelera Committee became the basis for this UCIS standard. So what is the data that we're going to put in there? So if you look at Questa, it generates these cover points. So maybe you have, a bunch of coverage bins. You have assertion coverage. You have code coverage. You have all these different types of coverage. And then each test, you run it, and it will create certain coverage of these different pieces here. And each test will be covering, maybe this test covers a couple of these bins. This test covers some stuff up here, this test. So we have the ability to merge and import all of that coverage data. So this is showing, that this test covered these bins, this test covered something else. So you get all this coverage out of these different tests. And then what the UCDB allows is for you to put your test plan in the middle of there. So your test plan is now saying, I have a transmitter section and it has these features. I have a receiver section and it has these different features. And so by linking these coverage items from your simulation to those things in your test plan, and then relating that back to the actual tests that are covered, you get much better project level information rather than just looking over here, which is kind of specific to the implementation. And it's hard to say that, this thing right here means that this mode of the receiver is covered. So we're kind of automating that, and I'll show a little more detail. So all of those different coverages I was talking about that get generated, all of those things go into this UCDB. And then each test that you run in your regression suite creates a UCDB for that specific test. And then I run another test and another test and another test. So I run all of these different tests, and each one of these is gathering this coverage data. Well, what we really want to know is what's the cumulative coverage of all those tests? Or even better, there is some cumulative coverage, but did this test contribute anything to that coverage? Was there anything special about that test? And so that's where we can do things like we can look at the individual coverage of each of those tests and see, that this test had, this amount of coverage on the cover groups and the code coverage and the statement coverage and et cetera. This test had, this coverage. By ranking those things, what it does is it says, this is the minimal number of tests, that if I run these 7 tests, that gets me the total coverage. And running this test here that's not there anymore, that didn't provide anything extra. So let's not use that in our regression suite. Let's trim our regression suite down to the minimal number of tests that we need to run. And so that is the merging and the ranking of all of those tests. And then once we do that, once we've merged all those tests together, there's a whole bunch of different tools we can use with that. So here's all of the different tests. This is the verification management browser within the Questa tools. And I can query it, and I can look at that merged data, and I can say, what's the fewest number of tests? Well, first of all, it says, what was this test? What engine did I run it on? So most of them here have been run on the Questa simulation engine. These 2 right here were run on our emulator. These 2 were run on our formal verification tools. all of these tools provide the same data format so that they can be merged together into this cumulative result. So I can do things like say, well, if I merge them all together, what's my coverage? So I merge it, and it says, if I merge them all, there was, well, this is the minimal number of tests that get me to, the maximum coverage value. So here I minimized on the number of tests. Here I minimized on the shortest amount of time. So I only ran, well, okay, this was the total, excuse me. This was all of the tests. And, it took 17 hours to run, and it got me to 67% coverage. If I rank on the fewest number of tests, I can see I only ran 8 tests, and it only took almost 7 hours to run that. I could do it maybe on the shortest run time, where in this case, I ran more tests, but because I was using the emulator, which was accelerating some of the tests, I actually finished in, 3 hours and 45 minutes. So those are the kinds of analysis you can do on the ranking. You can rank by different criteria. And basically, you're just looking for the set of tests that's going to provide you with the maximum coverage and either the minimal number of tests or the minimal amount of time to run those tests. And then you'll see here is each instance, what kind of coverage I had on it. It shows all the arguments that I used to run that test. That's embedded in there. So I can say, show me the test that had the highest amount of coverage. So a single test, this one got 84.84% coverage. So that's my best test of the group, this RAN test 2. I can say what's the minimal group of tests, and then this is showing the coverage tracking, which I'll show a little more about. Okay, yeah, this was the single highest test for different purposes. So let me go into more detail on that as I come along. So the first thing we'll talk now about after the database is we'll talk about the test plan tracking attributes of our verification management solution. So what this is all about is I have my design. I'm running a set of tests. So I'm running a set of tests through my verification engine. The first thing I ask is, did that test pass? If it didn't, I come over here into this debug flow and I say, okay, let's do the debug. Then the second question we ask is, if that thing passed, are we done? And if we are, great, we're done. If not, I have to go and create more tests. So how do we answer these questions? Does it work and is it done? And really, how do we answer this question, are we done? And that is to link the simulation results with that verification test plan. And so how we do that linkage is through the UCDB. So our simulation collects the code coverage, the cover points, the coverage data, all of that data, and then we merge our test plan. We create an empty coverage vessel that is annotated with all our test plan sections, and we merge that with our regression results, and that gives us a view of how are all those coverage objects that we're creating, how are they annotating onto that test plan, and what features are completely tested, what features still need work. And that's, done, as I say, through this UCDB. So that test plan can be in a lot of different formats. It could be in a Word document. It could be in probably our most common way to write a test plan now is through a spreadsheet, either an Excel spreadsheet or a OpenOffice spreadsheet or something like that. And then what that allows is for us to create that test plan, describe each of the tests we ran, and then put the linkage in between our coverage objects and that test plan object so that we can do the matching there. So for us, the verification process then becomes, let's create a test plan. Let's create a bunch of tests that are going to work on that test plan. We run all those tests and create a whole bunch of individual UCDBs. We do the ranking to find the minimal set of UCDBs. That creates a merged UCDB that is the cumulative coverage of all of those things. And then we link through these linkages our test plan to that merged data. And what then comes out is a view of our test plan where I can peer down and say, bonding mode 0 has 0% test coverage because these two cover directives were not activated and have not been simulated at all. So as those get simulated, this coverage goes up, that rolls up into the transmitter section, that rolls up into the whole test plan. So how do we do that linkage? So the first thing is we have an Excel spreadsheet template that we suggest you use. That template has a section heading, so the overall test plan, we're going to test the transmitter. How do we test the transmitter? We test bonding mode 0, bonding mode 1, a few other things maybe that aren't shown here, some frame alignment stuff, the data switch, different paths. So then we go down and, we have all these different sections in our test plan. And then we have a linkage column that says this cover directive with this name, if that has been sufficiently tested, then I will say bonding mode 1 has been tested. This cover directive tests bonding mode 0. This assertion right here tests, these outputs. This assertion tests path B. This assertion tests path A. That's the minimal number of things that we're going to put in. There's also a weight and a goal. So we can say, for instance, the transmitter is super important. We give that a weight of 10. We give the receiver a weight of 7. We give the CPU core a weight of 30. So we put all of those weights in there, and then there's a bunch of optional things we can put in as well. By default, the goal is going to be 100%, that you need to fully cover that thing. For whatever reason, you might back that off a little. You can put in what engineer is responsible for this section, what team they're part of, are they using simulation or emulation or formal or whatever. You can put in milestones, you can put in priorities, all kinds of optional features you can put in there. And to help you generate this, we have a Questa Excel add-in. So you install that Questa Excel add-in, that will create this extra tab in Excel that helps you to annotate that test plan. So what you can actually do is you can create your test plan from our template. If you have the Excel add-in, you can then say, okay, I want to read in my current coverage database. And that'll then show all the assertions, all the different types of coverage, all the cover points. And then you can select those and hit the different columns and say, this test plan uses these coverage objects to cover that. So it basically helps you to build up that test plan. So here I can create a test plan that creates an empty test plan. I start to fill in all the stuff on my test plan. I can then go and, read in a UCDB database and then start to annotate all those different pieces from my UCDB database. I can export that then as that empty UCDB shell that then once I run my test suite, I can merge all those or rank all those tests and create a merged or ranked database and then annotate my test plan with that merged database. So now I'm going to merge my test plan, and then this is what comes out is I can go down and I can look and I can say, right now I've finished 39% of my test plan. The transmitter section is 37% complete. The preprocessor section is 87% complete. The post-processor, 42. Why am I only 37%? I can drill down and say, well, my bonding mode 0 is 33% covered. And why is it 33% covered? Well, I've got this one cover point that is covered, so that's good. But then I've got these 2 directed tests that I say those need to run and pass. And so far, apparently, those either haven't been created or they haven't passed. And so those aren't covered. So my 3 objects for bonding mode 0, only one of them. So that, that bonding mode 0 is 33% covered. Bonding mode 1 currently is 70% covered. And then these all hierarchically roll up to the different section headings, which eventually roll up to the test plan. So, I can look now, once I have this test plan annotation, I can do all kinds of things. I can say, what is the link coverage for these different things? I kind of already talked about that. I can find the single test with the most coverage, and that'll say that it's this data set or data test TX data test, some random testing. I can filter all kinds of different things. So I can filter on maybe my priority 1 things. And the sad thing here is that my coverage actually went down for my high priority things. If I look at my lower priority things, you'll see actually my tests have been covering the lower priority pieces, which isn't really good as far as I'm concerned. We need to focus more on those high priority issues. I can filter by engineer. So I can see, Darren has 47% coverage. Alan is at 71% coverage. So maybe I need to put another engineer on these tests to take some of the load off of Alan to make sure we stay on schedule. Or I can look for things like, well, what are the objects that have no coverage currently? So here I've filtered on the 0 coverage, the coverage holes. And I can see all the things that I need to really, concentrate on to start getting some coverage on those things. I can see what team those people are on, when is each of these objects supposed to be done versus the date that I have. So all kinds of stuff like that. So the next thing is, now I've been running some tests and I want to start looking at historical data and do some trending analysis. The verification process is a lot of data, and being able to group and analyze that data both, on the data set and trends over time can be very important. So some of the types of things I want to do is I want to look at, I run, regression tests every night, and each one of those creates a coverage database. So what I can then do is group all of those historical coverages. So the Monday, Tuesday, Wednesday, Thursday, I can merge all of those total coverage things into what's called a trend database. And then if I run another set of tests, maybe on Friday, I can merge that one test into the existing trend database. And then on Saturday and Sunday and whatever. And then what I can generate from those trend databases is I can generate views of different things I'm interested in. So this is the total coverage view right here. I think I've got, there we go. So this is my code coverage. I can see that my statement coverage is moving in on 100%. I'm very happy about that. My branch coverage seems to have leveled off at about 82%. My functional coverage data, so that's all the cover points and things, that's trending up, but we're still only at about 80%. Need to get that to where I need to be. I can then look at my actual test plan and all those test plan headings, and I can see, the trending on those. And like, let's say I'm moving along, and at some point I see, well, I could swear a week ago we were at a much higher level on our microprocessor interface. What happened? So I look at my trend database and I see somewhere in the middle of March here, we dropped on our microprocessor interface, and that's probably because a whole bunch of new coverage objects were were added to my test plan, which, made it look like my coverage dropped way off. I can look at things like code base. So how many lines of code do I have? I can see it's sort of stabilizing somewhere around 22,000. I can look at the changes. My changes, see right here, that March 11, I did a bunch of changes, and that corresponds to when I had this big drop off. So now that's starting to drop back off to 0. I'm not doing a lot of changes, and the number of files that I have is leveling off. I can look at my tests. I can see, how many tests am I running? How many of them are passing? How many of them are failing? I'm trending towards, all of my tests are passing, none of them are failing. So that's the trend analysis we can do. The next aspect is results analysis. So this is, I'm running this regression suite, and maybe I'm running thousands of tests depending on the size of my project. And I, am getting a bunch of tests. Most of the tests are passing, but I'm getting hundreds and hundreds of failing tests. And I got to go figure out, why those are failing and rerun those as I make changes. So what I can do is by merging all of this together is I can create this merged database, which has all the failure messages into that merged database. And when I merge all of those UCDBs together, it tracks all of the failure messages, and it tracks what test produced that failure message. And so what I can do is I can either go individually debug all of those failing tests, or, what I can do is with our results analysis tools, I can merge it all together, and I can see the first can sort by error warning note. So let's sort and look at all the errors. So the first error that occurs in any test occurs at 20,435 nanoseconds. So I can see right here that this error happened in several different tests. So the first one was the register test, but I see that failure message actually happened in several tests, that 3 different tests put out that same message at the same time. So if I debug this message in this one test, hopefully that fixes this error in all 3 of these tests. In some cases, I might even see that, like here at 21,930, I had 26 different tests that put out that exact same message. And so by debugging this one, hopefully I'm debugging all 26 of those tests at a time. So I can filter these results by time. I can filter them first maybe by severity, then by the message that was put out, and then I can filter it by the test name and the time. So I can do all kinds of different filtering. In this case, I filtered it such that, maybe messages are coming off of channel A and off of channel B. And right now I want to focus on all the channel B messages. So I can focus all those errors on channel B, and I can debug error messages. And, if I debug this one message, I'll see that message was produced in a whole bunch of different tests. And again, if I fix that, I can fix many tests at once. So that's kind of the results analysis. We can go over this in more detail if this is something that you want to look more deeply at. And I even have a set of labs that are based on all this so that you can, run through on some data to see how this all works. And then the last piece of the puzzle is our verification run manager. And if you think about running your regression sets, there's certain things you want to do. You have to compile all the data first of all. Maybe you're going to build and run some block level testing on individual blocks, and then you're going to run some tests on your top level system. So, you might have a bunch of different tests that you want to run. Some of these are going to be directed tests. Some of them are going to be randomized tests where you're running the same test with different seeds. Once all those tests complete, then you have scripts that merge all the data together and to do the analysis. And based on the test that failed, you may need to rerun some of those tests for debug. So there's a whole bunch of stuff that goes into that. And generally, what happens is people are building these with like maybe Perl scripts or Linux, shell scripts or awk scripts or whatever else. And what we need to do is, or what the verification run manager does, is it comes up with a automated way to do this. So the typical regression system is that you are, kind of homegrown building all those scripts. It's fairly expensive to create all that and maintain it. A lot of times, I'll go into companies and the engineer who originally built the verification scripts is no longer there. So somebody else is required to come in and learn those and continue to maintain them. They're generally built with, as I said, shell scripts and things that are not necessarily verification tools. And then you're manually merging and analyzing, et cetera. The verification run manager, what it is it's our standardized way to build your build scripts, your run scripts. By using it, it automates some of the processes of merging results together and rerunning tests and all kinds of other things. So it is our regression control system is called the verification run manager. And so you create these, it is an XML database. We do have some graphical tools to help you build up that XML because editing XML is not necessarily fun. But once you have that, then you can, get a graphical view of what do I have to do to build my thing. Now, when I want to run tests, I'm going to run this test with 3 different random seeds. I'm going to run this directed test. I'm going to run this test with 5 random seeds. I'm going to run this test with 10 different random seeds. And so our vrun process will launch the verification. It will say, okay, I've got to build my infrastructure first, then I'm going to launch these tests. And it can either locally launch it on, a server. And if that server has, say, 4 processors and you have 4 license of Questa, it can run 4 simulations at a time. As one of them finishes, it'll launch the next one, etc. Or if you have a grid management system like LFS or SunGrid or whatever they're calling a grid engine, I guess is what they're calling it now, it can, say, okay, grid system, launch this test, launch this test. So the VRM will, do all the job management, and then what will happen is it will run this test. And let's say you're running in regression mode, so you're not collecting debug information. So it's going to archive the UCDB, the simulation log, and then potentially any waveform data that you would be creating. And then it will look at the results of that. If the test passes, it will automatically merge those results into a merged simulation database. If the test fails, and then you can merge that with your test plan. So as each test passes, it will automatically go into that merged database, and your test plan will continue to be annotated with the current coverage data. If a test fails, you can set it up to say, when I see a test fail, I'm going to automatically rerun that, but I'm going to use the options to, preserve all the visibility and collect all of the, wave data for that failing test. And so you run your regression system overnight, 99 of your tests pass, one of them fails, but it automatically gets rerun with debug information. So when you come in the morning, you can pull up those wave files and look at the debug information. And then it can also automatically merge that into your trend database so that you can look at your trending. And so if you use the VRM, all of these processes here are all automated for you, and you don't have to create scripts to do that. The Verification Run Manager has a cockpit so that you can look at, what's currently running, what tests have passed, what tests have failed. These are all completed running. We don't have any running tests right now. We don't have any that are queued. But if you're in the middle of a regression run, you'll see maybe that I have 10 tests currently running. I have this many passed, I have this many failed, and there's 10 more in the queue that need to still be run. So the cockpit, as I said, kind of looks like this, that you can look at the history, you can look at all kinds of data within there. And then this automatically will generate coverage reports in text. You can generate coverage reports in HTML so that they can be viewed in a browser by a project manager who couldn't turn on Questa if he had to. And we'll see right here that I've got 73 past tests, 18 haven't been run. I don't know why there's none in the queue. We must have terminated this run. So then I can look at test coverage. I can view it I can view the UCDB in the verification browser. That then will pull up the cover groups and cover data. I can pull up the verification tracker so that I can view the test plan and how I'm doing versus my goals. And as I merge more and more data in, it will update that test plan. So, and then again, you can do all of the same testing, all of the same filtering on the verification tracker that I showed you in the earlier section. If you need to rerun a test because it failed or because you made some changes, you can click on any one of those tests and say rerun it. You can say rerun it with debug. You can say rerun it in different modes. So all of this, as I said, if you use the Verification Run Manager, a lot of these processes that are normally manual are pretty much done for you. Oh, and the results analysis pane can be pulled up inside the VRM as well. So I'm going to give a quick plug for the Verification Academy. It is www.verificationacademy.com. If that's too much to remember, just search for Verification Academy on Google. It will be your first hit, and that will show you all the coverage. Or that Verification Academy is a website of verification topics. There are many courses that you can look at. So we have courses on test bench acceleration, on UVM. We have a section on verification planning. We have a verification cookbook, and then there is also an open forum on the Verification Academy. So I would highly suggest going there. I think I got these slides a little out of order because I added these Jenkins slides. So Jenkins is the Jenkins continuous integration. This is a system that as you check files in to your Vault, your revision control system, Jenkins will recognize that a file has been updated and it can be used to kick off regression runs. So a lot of people ask me about Jenkins and had a lot of desire to get there. So what we've done is we've created a plugin to Jenkins so that what happens is you have that continuous automation system. You check a file into your revision control. Jenkins will call the VRM, kick off a VRun process. VRun will run all of your verification, and then it will feed the data back into your revision control, and then you get a Jenkins portal that you can look at what the verification results are. So when you have that verification portal, your projects within Jenkins show all kinds of interesting data. So those trend maps, your code coverage, your number of tests you ran, all kinds of interesting coverage data is is automatically generated and placed into that Jenkins portal. So the summary is that Questa's verification management system will handle all three dimensions of your verification. So your verification process, the tools that you're going to use, and all the data that gets generated will all be handled there. The verification management system is modular, it's scalable from block level to system level, etc. It focuses on reducing the burden of generating your test bench, reducing the burden of running and managing all the data that gets created, gives you visibility into your project, allows you to look at trend data, and allows you to do a high-level regression suite debug rather than an individual test debug. As I said, the verification management package is an option to Questa Core, and it comes standard with Questa Prime. So at that point, I think I am complete with the presentation I was going to do. Let me see if there are any questions that have come in the chat window, and it looks like there has been. So I can run through some of those questions. How many tests the browser can support? I have 10,000 tests in some regression, and I wonder if it would be possible for the tool to do that without crashing or lagging. We definitely have a large number of tests, 10,000 tests. So I assume you're saying that you're creating 10,000 UCDBs, and the tool is perfectly capable of merging and ranking on a huge number of tests such as that. So it said, why did the merge reduce the number of simulation tests? So I think that was probably a merge and a rank, and we were ranking, saying we are looking at these coverage objects and we're getting rid of tests that are not producing any more coverage. If we do a rank, so another question on just the ranking, and as I said, you have different criteria that you can do on the ranking. So you can try to rank and get the minimal number of tests to run, or the minimal amount of time to run those tests. So lots of different aspects. When the design changes from bug fixes, how does the tool coverage database adapt to the new RTL, or do we need to rerun the whole regression database? So if you're making changes, generally the practice is to rerun the regression suite, because you don't just want to update on the changes because you don't know whether those changes had unintended consequences on other pieces. So if we can iteratively add new tests to the merge UCDB, how long does it take when merging 10,000 tests? The merging is, if you have millions of clock cycles, hundreds of thousands of tests, or tens of thousands of tests, it's probably a 10 to 15 minute to merge and rank them all. And then if you've got a merged database already and you're just merging in one more test, that probably takes not more than a couple of seconds or a couple of minutes at most. I presume UCDB consists of a single directed test. So when you run a simulation, you create a UCDB that has a single test, but then as you merge them together, that UCDB can be the cumulative merge, and it keeps track of, what tests provided what coverage. All of those features included with Questa Sim license, or it is an additional license. So Questa Prime, it is all included in. Questa Core, it is an additional add-on for the verification management product. Someone asked 10,000 tests in the UCDB. I have 500,000 to 1 million tests. Will my volume be a problem? It shouldn't be. We definitely have, customers like Broadcom and certain large semiconductor processor companies that don't like us to use their name, that have millions of tests, and we don't really have capacity issues there. So any other questions? I think I've answered all the questions that came in through the chat window. If there aren't any other questions, we are coming up on the end of our hour. And I just want to say thank you to everybody for spending the time here. Hopefully this was useful. And we thank you for your time and attention.